Good afternoon, everyone, and welcome to Improving's virtual Lunch and Learn. Before we get started, I wanted to inform you guys about a feature in the presentation that'll make it more interactive. Please take note of the question mark icon in the upper right of the presentation screen. If you click that icon, it'll allow you to push questions to our moderator, which can then deliver those questions to the presenter at the appropriate time. We're excited to present Eric Stevenich, a principal consultant at Improving, who's going to share with us an introduction into React development. Eric, take it away.
All right. So, thanks, Max. So, we're going to talk about React today. And for the most part, we're just going to cover a couple things here. There we go. So React is largely done with ECMAScript 6. So we're going to cover some of that syntax because a lot of people are unfamiliar with it. And that's one of the largest problems when you get into starting React development is you see all this crazy syntax and it's just new JavaScript that people aren't familiar with. The meat and butter of React is JSX. It's a HTML in JavaScript language. We'll talk about that. React hooks allow us to interact with our components and provide state and functionality. And then Redux is a global state management library that is really, really popular and kind of is just paired with React a lot. So starting on ECMAScript syntax. So why do we want to use ES6? So ES6 adds features that other languages have. JavaScript's been around a long, long time, and it hasn't been updated in a long time until ES6 came out. And so they added a lot of new features. They added better Lambda support. They added block scope variables, which haven't been around ever. Interpolated strings. It makes it a lot easier to read our code because of features like destructuring, classes. They introduced maps and sets, which previously you had to implement by yourself. And there's a bunch of bugs in JavaScript. There's this great little video of like all the things wrong with JavaScript, and ES6 fixes most of those just by fixing this, really, in general. And then adding promises to support Ajax and make it easier to handle those. So unlike languages like TypeScript that are compile time, ES6 is still runtime only. So we still want some style help while we're developing. One of the most popular tools out there is called ESLint. It integrates well with VS Code and other things and it allows you to just run your code through almost like a pre-compile step to warn you of syntax errors and potential bugs that are logic errors that syntax wouldn't. It's correct syntax, but it's a logic error. So you can get it from npm. You just npm ESLint. You have to install a config. It's all really easy to follow along for this configuration. I recommend the Airbnb config. It looks the most like regular JavaScript. And then I strongly recommend installing a plugin that runs it as you type. But we're not going to talk much more about that. It's just a word of warning. You should use it. So ES6 still has var. You've seen var in JavaScript if you've ever done JavaScript. It has all the same problems that JavaScript var has. So it doesn't have block scope. You can redeclare it. There's this weird thing called hoisting that happens. We don't really use var in ES6 ever. We can use let, which is like var, but fixed. For all the problems that JavaScript has, let doesn't have. It doesn't hoist. You can't redeclare it. It has block scope. It's awesome. And then the other variable keyword we use is const. And most of the time we actually use const. They're the same as let, but you can't redeclare them. You can't reassign them either. So once you declare const, that value is constant. It makes JavaScript much more of a functional language instead of mutatable language. And it really makes your code and React code a lot more reusable if you use consts wherever you can. Let's okay, but generally we don't use let because everything in React likes to be a const. All right, arrow functions. Arrow functions are the new ES6 Lambda functions. So in JavaScript, we could already declare anonymous functions just with the function keyword. Arrow functions allow us to take a lot of that boilerplate of writing out the word keyword function and then curly braces and return and allow us just to say variables arrow function body. So there's a lot of different ways you can write them. Here's some different ones here. They're a lot easier to read in code because they're smaller. There's less words around it. They look very similar to C#, for instance, or Java's now has them. So they're a lot easier. And the other advantage is they fix the word this. So if you've programmed in JavaScript long enough, you've run into a situation where you take a function reference and you hand it to another object and then you execute it and this is broken. Thank you. And this is broken because it's bound to the new variable instead of the variable you wanted it to. So with arrow functions, this binds at the time the function is declared instead of when it's executed. So it just alleviates a lot of the problems. If you look online in React tutorials, a lot of their class declarations will declare functions, and then in their constructor, they'll say this dot function equals this dot function dot bind this. It's really weird looking, but we don't have to do that if we just use arrow functions because they're automatically bound to the object at declaration time rather than execution time. So almost never use regular functions. Use arrow functions because they operate the way they're supposed to and the way that you expect them to, and the way that other languages do it. And that's a lot of what ES6 is doing is it's just making JavaScript conform to other languages instead of the weird thing it used to be. Another interesting thing ES6 adds for us is interpolated strings. So instead of having to quote string quote plus variable plus quote string quote plus, you can just use backticks and then inside of it you can do $ curlies and put JavaScript expressions inside. And it allows you to interpolate strings. Any JavaScript expression can be inside that. Again, try not to put 500 lines of code inside an interpolated string. You might want to pull that out into a function. Backticks, interpolations, and $, you just double $, is if you actually have to insert a $. Destructuring, another really handy tool that provides concise explanations of where variables come from. So normally in JavaScript or any other language for that matter, if you take in an object and you want to have a local reference, then you have to declare a variable and say, const myvar equals the object dot myvar. And normally you're naming it the same thing as the thing in the object. So destructuring allows you to declare the variable and extract it from the object in the same step. So you can use them in arrays and objects. They both destructuring works. Arrays are destructured by position. Objects are destructured by name. They can be either, you can destructure parameters as well as variables. It doesn't have to be done in the parameter array. You can just do it in anywhere, really. You don't have to take all the values either, which is nice. So for instance, in our clone method here, we are only taking out the name and the breed. We're not taking the age out of the object, even though it's coming in. So that is the first parameter. We're taking the variables name and breed and declaring them as new constants inside of our clone method, named name and breed. And then array destructuring is positional based. So we're extracting out the first and the fourth indexes. And you can see that you can just skip indexes with comma. So if you only want the second element in an array, instead of having to go const my thing equals array at 1, you can just do square bracket comma my thing and get it out. it really makes the code a lot cleaner and a lot easier to read where values are coming from, because it just cuts down on the number of lines of code of setup in order to get the data you need. All right, JavaScript ES6 also added Varargs. So traditionally, JavaScript has variable arguments, but you have to use that arguments keyword, that special weird pseudo variable that exists inside JavaScript functions. And it's really weird, and it's not really an array, but it acts like an array. So they got rid of that. You could still use it, but you can't use it inside arrow functions. You can only use it inside regular functions. If you need Varargs, you use Varargs like every other language. The last variable can be ... dotted, and it turns any additional variables passed into an array. So we could invoke add 2 or more by calling add 2 or more, open parenthesis 1, 2, 3, 4, 5, 6, and 1 will be passed in as A, 2 will be passed in as B, and 3 through 6 get made into an array named rest. It doesn't have to be named rest. Generally, you want to name it something that is obvious that this is an array and not just useless data. And then at that point, it's an actual array. You can use array objects on it. You don't have to do any manipulation to turn the arguments thing into an array. So just like destructuring, spreading is the opposite way. A lot of times you have an object and you want to clone it, and you want to apply all the properties onto it. You could have used something like low-merge or object.assign, but again, those have their own problems. Spread allows you to just take an object and ... it when you're handing it to something else, and it will take the properties of that object and explode them out into the place you're applying it. So again, you can spread objects or arrays. I didn't show any arrays here, but it's the same way. It's just array syntax instead of object syntax. So if you had an array of even numbers, an array of odd numbers, and you open square bracket ... evens, comma ... odds, it would return an array of both of them combined. Fields are applied, when you spread an object, they're applied top down. If there's any duplicates, the one further down in the code takes precedence. So in this example, A and B gets overridden with 5 in E, and C becomes meow. Yeah. So the later one is what applies. And then the last major thing that's new to most JavaScript developers are promises. So promises are used all over the place in React code and ES6 code. They are the way asynchronous code is done in JavaScript without async await. Async await, again, it's weirdly supported. In some situations it's supported, in some it's not. It generates some really weird looking code if you use async await. Promises are clean, they're effective, and they work in most major browsers now. Obviously, probably not IE10, but who uses that? So promises allow you to return values later. It replaces callbacks. So generally in old JavaScript, if you wanted to write a function that allowed you to perform something on a timer, you would write a function that took in the amount of time and then a function as the second parameter, and you would execute your timeout, and then you would pass the function that you got passed into the timeout. With promises, we can alleviate all that and just go, hey, we want to execute this promise, and then we want to do some stuff after it executes. They also allow you to add in error handling. So if something goes wrong in that promise, we can catch that exception and know that it wasn't a correct error or a correct response. Otherwise, you have to go in, like before, you would have to put in some weird, be like, oh, if this fails, then I'm going to execute your function with this certain data structure that shows an error. And if it's successful, the data structure will look like this. Now you can just be like, the success is the then, and the catch is the error. Promises can also be chained. So you can do .then. Catch if there's an error in anything, so you don't have to put a .then.catch. You could just do then catch, and it'll catch any errors in the entire promise chain. So they're used all over the place in React. They're great. Most of the time, you won't see new promise because most of the time you're consuming a promise, you're not building your own. So that's pretty much all the syntax differences that you'll see often. The only other major syntax difference that's brand new to anyone that's not done React is JSX. So why do we want to use JSX? JSX is HTML in JavaScript. It allows us to embed our HTML directly in our JavaScript files instead of doing something like Razor, where you've got your CS HTML files that are all your HTML with C# in them, and then your script and your JavaScript somewhere else. It makes it really easy to see the structure and the function together. And you can nest these infinitely, of course. And if you do that, that's a bad thing, but don't. But you can. So you can put JavaScript inside JSX, you can put JSX inside JavaScript, and it can just go back and forth. JSX is much more descriptive than writing all this in raw JavaScript. It compiles down to raw JavaScript, so you could totally write your entire React app with react.createElement. It would look terrible and be hard to maintain, but you could do it. It's just a syntax difference. And JSX is composable. It allows you to take your giant application and break it down into its component parts and make those reusable so that you don't have 15 button implementations. You have one button implementation and you just give it the data it needs for that instance. So components. So JSX components are just functions. They're plain old JavaScript functions. There's nothing fancy about them. There's nothing new. If you can write a JavaScript function, it could be a component. The only thing that makes them anything special is they take one argument and it's named props, and they return JSX or anything that's renderable by JSX. So most of the time you won't see someone taking in the word props or one argument and then taking values out of it. You'll just see them destructure the properties out of the argument. So you can declare a function and then you use it just by using standard HTML syntax, and the name of the function is the name of the tag, and then all of the HTML attributes become properties in the property argument, and their value is whatever you set it to. You can use curly braces or strings if you want, but it really just depends on if it's a hard-coded string or not. Most of the time you'll see curly braces. And yeah, every component you write is going to be a JSX type return. And other than that, there's HTML. You can put any HTML tag you want in there. It is just HTML. Components have to be capitalized. They're Pascal case. If it's lowercase, it doesn't know it's a custom component, and Chrome will yell at you loudly that that tag doesn't exist. So if you name it capitalized, React, everyone knows that this is a custom component. So an example, you might want to declare a table. Tables have rows. Rows have data in it. So if you want, you can declare a table, you can declare a row. The table can use the row. The table can take in the data. And then you can declare data just as a regular JavaScript array and hand it to the table. There's no manipulation into React constructs or anything like that. It's all regular JavaScript data. It's regular JavaScript functions. The only difference is that you put it inside tags. And then inside your components, you can also drop curly braces and drop into JavaScript like we do for iterating over the data and mapping it to rows. We just use the standard JavaScript array map function. You get a row object, we use an arrow function and declare a new row object. And it declares it and executes it. So, a couple do's and don'ts of JSX. Do try and keep your JSX code and JavaScript code separate. If you take your JavaScript code and you embed it in your JSX, then you're not really taking advantage of the features that JSX and React are giving you. It makes it really hard to read your code because you're sitting there and your brain's going HTML, 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 JavaScript, HTML, JavaScript, and it gets really, really confusing. So like something like this, where it's just a map function, that doesn't need to be extracted out into its own function. But the row makes sense to pull out because otherwise you've got a map with a little bit of JavaScript and then a bunch of HTML to read, and it makes it really hard to read. So it's easier when you have just a bunch of HTML and then a couple of JavaScript things that call other components. So smaller components are easier to, that should say, read and understand. So they're easier to read and understand because they are, you don't need to read 300 lines of code to understand what's going on. You can look at it and go, oh, that's a table, and that's it. It makes it really easy. Don't be afraid to make more files. Files cost you nothing. Make lots and lots of files. Separate your code out into separate files so that when you make a change, you can go in and read it. When you want to reuse something, it's already split out. It's a lot easier to start with your files split out into small files and combine them than it is to take a giant monolith and try and split it up. When you're like, oh, I need to reuse this table. Well, if it's embedded in a 300-line component, you're going to spend a long time splitting that out instead of going, well, I already split that out into a table and it needs a little bit of tweaking to make it reusable the way I need it. So make lots and lots of components. And definitely don't rewrite all of HTML. You have divs, use divs. Like we don't need to make a component called box that's just a div that does all the same stuff div does. Just use a div. Sometimes you'll make utility components, like I'll make a button if it's a styled button. I'll also make like a flex component that has display flex and allows you to specify a line and justify so that you're not writing style tags onto all your divs. You can just be like, hey, this is a flex row. It's aligned center. But don't rewrite everything HTML does. You just don't need to. All right. The React website has a fantastic in-depth JSX guide. If you follow it along, it's really easy to learn everything about JSX. There's a lot more that I didn't cover, but there's a lot of edge cases. So that's a great resource. The React documentation in general is fantastic. Like it's one of the best for any sort of framework I've ever used. Like their documentation is clear, concise, and they cover all the edge cases. All right, so that brings us on to React hooks. So components are the things that we build React apps with. And by default, components are read-only. When you pass data in, it renders the component, and that goes to the browser. If you want to start being able to change components and change data within your React app, you have to start introducing something called state. And back when React started, they created these things called class components, and they introduced state, and they looked like C# classes, JavaScript classes, and you had this.state, and you had this thing called setState, and you could do all this cool stuff and hook into the lifecycle and everything. But as React grew, it got really, really convoluted. And all the lifecycle methods that they were introducing and going, oh, now you can do something when this component re-renders. Oh, now you can do something to see if this component should re-render. And they kept adding more and more lifecycle hooks. And what ended up happening is these lifecycle hooks were not uniform. They were hard to remember or what the syntax was and what the names were. And it was really easy to make mistakes and end up in a situation where your app works, but there's hidden error cases that sometimes will just fail because you did an AJAX call in a place you shouldn't have, or you executed some code wrong, or you didn't check the right variable. And it could really hurt your React performance. And so at some point, they decided that they were just going to move away from that. Now, class components are still there. You can still use them. You don't have to rewrite your entire app with hooks. It's in big, bold letters when you read about hooks. Your class components will continue working the way they do. What hooks allow you to do is introduce state into functional components. It's a lot more expressive, it's a lot more declarative, and it's easier to read and understand what's going on. You can also compose hooks into reusable functions and allow you to reuse functionality across your app without writing higher order components, essentially. So the hooks that React has currently are useState, useEffect, useCallback, useMemo, useReducer, and useContext. And then, like I said, you can write custom hooks that are composed of these other hooks. So you could write like a like I'll show you later, a use media hook that allows you to hook into a media listener. So when the screen changes, something happens. So a lot of things happen, a lot of cool things you can do with hooks that allow you to declare what you're doing and be really expressive about what your code is doing instead of worrying so much about memorizing all these lifecycle things. So only a couple rules of hooks. You can only use them in functional components. You cannot use them in class components. They hook into the React lifecycle management. The only things that hooks can't do that class components can do is they have error boundaries with component did catch and get derived state from error, and get snapshot before update doesn't have a corresponding hook. But those three lifecycle events were very rarely used, so they felt okay releasing hooks without them. They have said that the error boundaries will be introduced at some point when they figure out a nice way of doing it. But until then, if you really need error boundaries, you'll just have to write a class component, one class component somewhere that catches your error boundary. And you can mix hooked functional components with class components, or vice versa, but you can't use hooks inside the class components themselves. Yeah. You can only call hooks from the component scope. You cannot call them inside for loops. You cannot call them inside if statements. You cannot call them from other functions. It has to be in the root of the component function's function scope. They have to execute in the same order, and all the hooks have to execute every time the component renders. You can't be like, oh, if this value isn't here, return null, and you call a hook after that, because that hook may or may not execute, and React can't handle that. You have to execute all the hooks every time in the same order. And then you can only call them from React functional components. You cannot call them from JavaScript functions, right? If you do it from inside a regular JavaScript function and you invoke that outside of the context of a React component, React is going to go, I don't know where you want me to declare this state thing, or how you want me to bind this hook in. It's not JavaScript, right? So you can't do them in a response to an AJAX call, because that's not inside the component. That's inside the response to the AJAX call. And then to help you with all these, again, there's another great ESLint package. It's called ESLint plugin React hooks. You attach it. It's a plugin to ESLint, and it'll warn you and be like, hey, you're calling a hook outside of a function, or hey, your dependency array doesn't match, or hey, you're missing this dependency. And so it allows you it'll catch all those errors and warn you about them all. So again, another plug for ESLint. It's great. So React useState. This is the basic building block of state management. So we like our data to be able to change. If we didn't want to change our application, we should probably just write some HTML. We don't need React if all we're doing is displaying data. So what sets or useState does, it allows you to declare a single data point that can change. The return value from setState or useState is an array, and the reason it's an array is, again, for destructuring, to make it look a lot more readable. So we declare that the first value from the array is our value, and the second value is a function that we're calling setValue. So if we didn't want to call these value, we could name these, cost and set cost, or name and update username, right? You can name them anything you want. They don't have to be named value and set value or blah and set blah. That's why it's an array declaration instead of an object. If it was an object, it would have to be named exactly what it was in the object. And then what you pass in to useState is the initial value. So in this case, we're starting at 0. There's no reason to say that that couldn't be 10 or 15 or 20. Yeah, that's it. You use value. Value is a value at that point. You can curly brace it and show it in JSX. You can console log it. It's just a regular JavaScript value. When you call set value, however, it will update the value and cause the component to re-render, which means the function re-executes. So every time you call that setter method, the function re-executes and the component re-renders. So when you set value plus 1, when we click that button, it's going to update the value and re-render, and value will now be 1, and then it'll say the current value is 1. If we click it again, it'll say 1 plus 1 is 2, set that into the value and re-render the component, and now it'll say the current value is 2. So I think, yep, that's all of useState. It's pretty simple. You use it a lot if you want things to change inside of your component. So the next type of hook is called useEffect. What useEffect does is it allows us to declare a function that we want to execute when certain conditions are met. So this function executes every time the component re-renders, and it will execute the function that calls setValue value plus 1 every second, in 1 second. So the component will render, and it'll execute that function, that useEffect, and that calls set timeout, and that's going to set the value to value plus 1 in 1 second. So after that component renders, 1 second later, that'll execute and will re-render the component, which will cause another timer tick every second. So this is essentially a clock that updates every second. The useEffect, the function you pass to useEffect, has to either return undefined or another function. The other function is used for cleaning up, like in our case, if we wanted to clear the timeout, we could return a function that calls clear timeout. All right, so the second argument in useEffect is the dependency array. And this is really where the power comes in, and why useEffect is more readable than the old React lifecycle management. So in old React lifecycle management, you had component will update, component did mount, component should update, and there's a whole bunch, there's like 2 other ones that you can do when the component's re-rendering. I want to manipulate state. Get derived state from props was another one they introduced. There's like 4 different ways to do it, and it was really confusing in which one you should use when. And if you use the wrong one, your app wouldn't render properly all the time. So with useEffect, they consolidated all of that down into 1. So the useEffect takes 2 arguments. The first is the callback, the effect, and the second is a dependency array. So if you pass no array, the effect will execute every time the component re-renders, which means that in this case, our effect is going to execute every time, and we may not want that. We might only want this to execute once. So we could say, hey, pass in an empty array. An empty array is an empty array. It has no dependencies, so the dependency array is never going to change. So the effect is only going to run when the dependency array runs, which means since there's no dependencies, it executes once. And if you pass in values into that dependency array, the effect will execute every time the component re-renders, and the value has changed in the dependency array since the last render. So if we use the first and the third use effect in conjunction, the first effect would set timeout and every second re-render the component. And the second effect would say, oh, the value changed, so I'm going to console log it. Oh, the value changed, so I'm going to console log it. But if another component caused our counter to re-render for whatever reason, the second use effect wouldn't, or the third use effect in here wouldn't re-execute if value didn't change. It'll only console log if value changes. It won't log, 70 times a second or however fast React can re-render, right? It'll only do it when value changes. So this really allows you to be like, okay, I have data, and when that data changes, I want to do something with it. It makes it a lot easier to read and understand where data is coming from and why the data is the way it is. Another hook is called useCallback. It allows us to declare a function that changes only when the dependency array changes. It looks a lot like useEffect. The difference is it returns a value instead of executing the function. It returns the function. The function is the same reference as long as the dependencies don't change. This is important because it prevents re-rendering every time the component renders. So if you declare a function in a const, and you say const onSubmit equals open parentheses, arrow, whatever, and then you use that onSubmit later in a form, every time this component that declared it renders, the custom form is going to re-render because the function's changed. And one of the ways React works is anytime a property changes, the function has to re-render. So that custom form would be re-rendering every time our component rendered, even though nothing changed in it. So by using useCallback, we can make it so that that custom form, if nothing changes inside of it, it'll go, oh, I can just rip that out of the DOM, re-render my stuff, and insert that back in, and it really speeds up rendering. So try not to declare just raw Lambda functions inside your components because they will cause re-renders, unnecessary re-renders. useCallback alleviates most of those. Very similarly, there's another function called useMemo. useMemo takes a function and it executes it when the dependency array changes, and it returns the results of the function instead of returning the function itself. So yeah, it again only recalculates when the dependencies change, prevents re-rendering of components, and in useMemo's case, you generally use it when you're doing some complicated value that you don't need to re-render every time. If you're doing like a title and the title is an interpolated string, you don't need to use a useMemo. You're just cluttering up your code. You can just say const title equals, page 1. That's not an expensive operation. If you're doing something that iterates over a collection of 10,000 items and filters out the even ones and then maps them into some other form, that would be really expensive to re-render every time this component re-renders and recalculate. So you might want to drop it in a useMemo and say, hey, only recalculate this when our data array changes. And then it can go, oh, it didn't change, so I'm just going to use the value I already have. So it really works nicely. The only difference between useMemo and useCallback is useMemo would be a function that returns a function if you didn't want to use useCallback. useCallback just reads easier, but they're functionally the same thing. And you cannot use Ajax and useMemo. useMemo has to return a value. If you don't return a value from useMemo, the value is going to be undefined. You can't do Ajax because Ajax returns promises not values. So yeah, if you want to do AJAX, you have to do it in a use effect and store state and call set state when in the .then of the promise for the AJAX. And then custom hooks. So all of this comes together and allows you to go, hey, I have functionality that I want to reuse in different components, but I don't want to copy paste because copy pasting is bad. So what you can do is you can write your own hook and use hooks inside of your hook, and then you can just invoke your hook and use your hook just like a regular hook. So in this case, this is a use media hook. This is, I'm pretty sure I grabbed this off Stack Overflow somewhere. But basically, we're declaring a media query, and we're watching on the media query, and then we're updating when the media query changes. And we're binding into browser functionality that is not React. So React doesn't know about listeners or window listeners or browser listeners or anything like that. So we're just declaring a window.watchMedia and giving it the media query we're watching. And then every time that happens, we update our state and then return our state from this. So this allows us to bind into that window functionality. You know, you can use custom hooks and use effects and set use state to bind into jQuery plugins that you already have. If you have an existing application that's written in jQuery, you can write a custom effect and a hook to grab and execute that code and inject it into React in a way that React can understand. Without having to rewrite your entire application. You could do the same thing, like if you have Angular parts on a page and you can grab data from that, you can write custom hooks that bind in and grab the data from that and expose it for React. It's really, really powerful. And so custom hooks, they have to start with the word use. It's so that React knows it's a custom hook. If you don't start your function with the word use, React is going to yell at you in the browser and say you're using a hook inside of a JavaScript function that's not allowed. If it starts with the word use, React ignores it and assumes it's a custom hook. You can use any other hooks. You can use custom hooks inside custom hooks. You can nest them. It works just fine. All the rules of hooks still apply. You can't use them inside if statements. You can't use them inside for loops. You can't put them inside AJAX responses. The same effects have to execute every time. All those rules still apply to custom hooks. Yeah, and with that, that's pretty much all hooks. There's two other ones I didn't cover. There's use reducer and use context. Use context exposes the context API. If you know you need context, then you're already past the level of this presentation. And use reducer we'll talk about here in a second. So Redux. So React state management, React state has to exist in the top component because state flows down and it can't flow back up. So if you declare state in child component, the parent can't access the child component state. So if you write just a pure React application, what you end up with is your top level application has all the state of your application, and then it has to hand that down to all the child components via properties. And so your child components, even though they're not actually using that data, they need to receive it so that they can hand it to their children. And you end up passing in just boatloads of properties that you're never actually using, but you're just forwarding on, so that your button down here knows what item up here it's working with. So it gets really complicated really quick if you're doing anything more complicated than a to-do list. So what Redux does is Redux is global state management. And a lot of people hear Redux and they go, oh no, Redux is bad. Well, Redux is not bad. So a lot of people say that Redux is replacing React state, and no, that's not right. You don't use Redux to replace React state. They're doing two completely different things. React state is used for maintaining component state. That's the state that that component is in, right? We have a form. The form maintains the state of the form, the data in the form fields. However, global state of your entire application, the current logged in user, right? That's something that is used all over the application. That should live in Redux, right? The actual data you're working with can live in Redux because that data is used everywhere, not just in this one form component, right? If you take your form component and stick it in Redux, that's overkill. It doesn't need to be there because it's not global. No one's using that data other than this form, so it should just stay in its component. So the other hook I said, use reducer, the use reducer hook. When React hooks launched, all of a sudden there was a slew of people writing blog posts that saying, you don't need Redux, you can just use reducer. And it's like, yes, you could totally use reducer, and they're functionally almost identical. The difference is use reducer is not global state. You're not using global state, you're using component state that looks like Redux. So you still have the same problems of passing your data down and having unnecessary props that you're not using. They're solving two completely different problems, and saying use reducer replaces Redux is missing the point of Redux. And any component can be connected in Redux. You can take any component and you can wrap a connect or a use selector or use dispatch in it. Not all components should be, is the caveat to that. So reusable components probably shouldn't be connected to Redux. Writing a component that's React and then binding Redux to it works a lot better, because then you're saying, okay, this is the functional reusable component, and here's how I'm using it, right? And that allows you to reuse the component if you have a different how I'm using it part. But like a label doesn't have to be, if you have a styled label, don't bind that to Redux. Just grab it in the component and pass the data in. Yeah. All right. Redux, like I said, what's it good for? It's great for global state management. That's the selling point of Redux, is everything's there. We are taking our business logic out of the views and moving it into reducers and actions. It allows your React code to do the React thing, which is rendering things and maintaining component state, and takes all of your business code of what does it mean to add something to cart? What does it mean to add an item to the to-do list, right? It allows you to take all that stuff and move it out into JavaScript functions that you can evoke from anywhere in your application without having to pass in new pipes to get the data there. And the Redux tenants, predictable, debuggable, centralized, and flexible. All of these are things that Redux enables through the Redux dev tools. You can actually do time travel debugging with Redux. You can apply and unapply actions as they fire to change state and go back in time with your application. You can do some really powerful stuff. All right, actions and reducers. Actions and reducers. These are two halves of Redux. Actions are what your application is doing, and reducers are what your application, or what happens when the data updates. So they're different. They shouldn't be one-to-one. You shouldn't have one action with one reducer. That doesn't work out well. You end up writing a lot of extra code. So actions are almost messages, right? Something has happened. You can put your AJAX in there. This is where your business logic goes. If statements, stuff like that. And you want to organize your actions by your business logic units. So you want to build actions like add to cart, like add item, delete item, rename item, not item added, like not building it based on view things like, hey, button clicked. No, what did we do? We added to the cart, right? That's an action, not I clicked the add to cart button. Reducers are mapping your data from the action and injecting it into the store. They are pure functions, has to be a pure function. And what that means is that if I have given a state and an action, it should always produce the same result. Always. It should be predictable that that action produces that result. So anytime I dispatch that action, the reducer fires in exactly the same way. They should really be organized by how the data is used rather than how it was applied or how it was dispatched. So like carting, the add item to cart method or action might fire, and your cart reducer might listen to that and grab the name and store it so that your little drop-down cart can show it. But your main cart page might be pulling all the extra data out of that and storing it in a different way. So a quick example, Git, it works really well. So Git has a state, your Git repository has a state. It's got branch names, stashes, commits, remotes. You could dispatch an action such as remote add a remote, and you pass data along with that action. Our reducer looks at it and says, hey, if this is a remote add action, then we're going to take the remote, create a new remote, and return the new state with that remote. And through Redux magic, the state will update, and now all of a sudden your Redux state will have 2 remotes. It's really, really simple. It's deceptively simple. It works very well. And the important thing is that like Redux doesn't have to be difficult. It sounds overcomplicated, and if you get in somewhere where it's been built weird, then it's really hard to follow along. I like to organize my actions and reducers via a grid, kind of thinking of it like a grid where my actions are domain actions. They're things my application does, right? I might load a list item. I might load an item individually, right? I might add to cart. The views, however, are not bound to those actions. You'll notice that I'm not saying load item into list, right? I'm not saying load or go to detail view, right? Those are things my application does, but they're not actions of my business logic. So your category view might dispatch the load item list and the load item, right? It's going to call load item list, get back some responses, and it's going to go through the load item list success reducer. And then it's going to dispatch, it's also going to dispatch out that, hey, I loaded these 15 items, right? The details reducer might listen to that one and have the last one ready that ever got loaded. It's like, hey, you called load item. This is the detail of view that it's going to go to. When you jump to the detail view, it already has the data on it, right? Same thing with the cart. The cart might listen to the load items and the add to carts, but it's not going to do anything with it, right? It's never going to dispatch add to cart, but it doesn't have to. It can just listen to it. So your reducer slices are organized by views. So your view, you might have multiple reducers listening to the same action and extracting different data from it, depending on how that view is going to use that data, rather than having a different action for each view, or even worse, building a database in Redux, where now you have your SQL database loaded into JavaScript memory and you have to query it every time to get the data you need. So build your reducers by view, and build your actions by domain logic, business logic. All right, that's it. Now I have questions. How did I do? I did really bad.
Thank you, Eric. Our first question is, how would you tie in WebSockets such as SignalR into React?
WebSockets. So I'm not terribly familiar with WebSockets. I haven't looked at their syntax closely, but it would probably be something, again, like useState, useEffect. I assume that WebSockets have some sort of callback mechanism that you can stream data into and to function as it receives data. You would probably write an effect that attaches that callback listener and calls setState a whole bunch, or has a use reducer or something that will take the stream of data from WebSockets and inject it into a state variable.
You talked a little bit about class components and functional components. Are there any further reasons you would use one or the other?
For the most part, I like using functional components. It's just a personal preference style. Class components I found get larger and a little messier. I've seen them get bigger and messier. Functional components are a little bit more reusable because you can extract that data out via hooks into custom hooks and then reuse that hook in different other functional components. Class components, there's not a lot of benefit to them. I don't see a lot of benefit to them anymore after hooks came out.
Another question on Redux is, would you prefer Redux Saga or Redux Thunk?
Thunks versus sagas. I like thunks, but sagas work too. Thunks are, I find they're a little easier to read. Sagas use ES6 generator functions. You have to set up your Babel and your Webpack to work correctly with those, and they generate some weird looking code. Thunks are just simpler implementation wise. In the back end, they just are thunks. They just execute a function. So there's less magic.
Thank you. And our last question today, Eric, should I use React or Angular?
It depends. I mean, there's Angular is a framework, or is a entire framework, and in order to use Angular, you need to learn all the Angular paradigms and the way Angular does things and the tools Angular provides for you. React is a little bit like the Wild West, where you want to use Axios, go use Axios. You want to use RxJS, go use RxJS. You want to use thunks or sagas or Redux, go do it. Like, they don't have dependency injection because they don't need it. They don't have services because they don't need it. React is a library. Angular is a framework. React is a rendering toolkit, and Angular does everything. You can do React in TypeScript. You can do Angular in ES6. I don't know why you would, but yeah, like, you can do React in TypeScript just fine. You just have to set up the tool chain to build it. But it really depends.
Awesome. Well, thank you guys all for attending today's virtual lunch and learn with Improving, and thank you, Eric, for sharing with us. The recording of this session will be available tomorrow at the virtual events page on improving.com/virtual-events. We hope you all enjoy the rest of your afternoon. And if we didn't get a chance to get to a question that you would like to have answered, if you could just email that question to marketing@improving.com, we'll make sure to get it to Eric and have him respond back. You guys have a great rest of your afternoon, and thank you.
Is that it?